Hello everyone, I am Pavitra Devi working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science in Dr. S.N.S. Rajeshmi College of Arts and Science. Now I am going to take the class about the multi-core programming. First, what is multi-core programming? Multi-core helps to create concurrent system for deploying or multiple core processor and multiprocessor system. A multi-core processor system is basically a single processor with multiple execution core in one chip. It is multiple processor on the motherboard or chip. A field programmable gateway (FGA) it might be included in a multiprocessor system. FPGA is the integrated circuit containing an array of programmable logical books and a hierarchy of reconfigurable interconnects. Input data is processed by produced outputs. It can be processed in a multi-core or multiprocessor system or FPGA. The multi-core programming approaches has following advantages and minus. Multi-core and FPGA processing helps to increase the performance of embedded system. Also helps to achieve scalability so the system can take advantages of increasing number of cores and FPGA processing power over time. Concurrent systems that we have using multi-core programming have multiple tasks executing in parallel. This is known as concurrent execution. When multiple parallel tasks are executed by a processor, it is known as multitasking. A CPU scheduler handles the task they executed in parallel. The CPU implements the task using operating system threads so that the task can execute it independently but have some data transfer between them, such as data transfer between the data appreciation module and controller of the system. Data transfer occurs when there is data dependencies. Next one, challenging of multi-core system. Since multi-core system consists of more than one processor, so need it have all the busy so that can make better use of multiprocessor computing cores. Scheduling algorithm must be designed to use multiple computing core to allow the parallel computation. The changes is also modify the existing and new program that are multi-thread to take advantages of multi-core system. The general 5 areas present challenging in the programming for multi-core system. First one, dividing activities. Challenging is to examine the task properly to find areas that can be divided into separate concurrent subtasks that can be executed parallelly or individual on the process to make complete use of multiple computing cores. Second one, balance. While dividing the task into subtasks equally might be ensured such that every subtask should platform almost equal amount of work. It should not be cases that one subtask has lot of work to perform, the other subtasks have very less to do because multi-core system programming may not enhance the performance compared into the single-core system. Third one, data splitting. Just the task is divided into smaller subtasks, data accessed and manipulated by that task, so divided into run different cores so that data can be easily accessible by each subtask. Next one, data dependencies. Since various similar subtasks running different cores, it may be possible one subtask depends on the data from another subtask. Next one, testing and debugging. When different smaller subtasks are executed in parallel, so testing the debugging such a concurrent task more difficult than testing debugging single-threaded applications. Next one, multi-threading model. Multi-threading model are the 3 types. First one, many to many, many to one, one to one mode. Multi-threading allows the application to divide it into tasks, individual threads. In multi-threading, the same process or task can be done by a number of threads. We can say that there is more than one thread to perform the task in multi-threading. Within the use of multi-threading, multitasking can be achieved. The main drawback of the single threading system is that only one task can be performed at a time. So to overcome the drawback of this single threading, there is multi-threading that allows the multiple tasks to be performed. Multi-threading model are the 3 types: many to many model, many to one to one model. Next one, many to many model. Ma'am, in this model, we have multiple user thread, multiple to the same or lesser number of kernel level threads. Number of kernel level threads are specific to the machine. Advantage of this model is if the user thread is blocked, we can schedule other user thread to other kernel thread. The system does not block if the particular thread is blocked. If the best multi-threading model. Next one, many to one model. In this model, we have two multiple user threads mapped into one kernel thread. In this model, when the user thread make the blocking of system, entire process blocks. As we have one kernel thread and only user thread can access the kernel at the time. So multiple threads are not able to access multiprocessor at the same time. The thread management is done on the user level, so it is more efficient. Next one, one-to-one model. In this model, one-to-one relationship between the kernel and the user thread. In this model, multiple thread can run multiple processor. Problem with this model can creating the user thread require the corresponding kernel threads. As each other user thread can connect to different kernel, if any other thread make blocking system call to other user thread won't be blocked. Thank you.